I want to tell you the best story that I have ever heard. And it has the added advantage of actually being a true story. Now, I'm an astrophysicist, which means that my profession, my passion, is studying things in the universe that are incomprehensibly large, they're extremely far away, they're very old. The numbers, really, the human brain doesn't even comprehend them. And I think sometimes people don't realize that scientists actually do respond to this with some emotion. People often ask me, what's it like to be an astrophysicist when you learn all these things? Does it affect the way you view the rest of your life? And the answer is yes. It's changed the way I view absolutely everything. And I want to tell you that story because I never responded to science just as the mathematics, just as the technical aspects. I responded to the story and to the drama of it all. And this morning I want to talk to you about, as I said, my favorite story is where we all come from. And in order to start that story, we need to go to some very, very large scales indeed. Now, this is a galaxy. Every image I'm going to show you today is a real picture taken by a NASA mission. This is from the Hubble Space Telescope. And a lot of people know the word galaxy. That's okay. But I don't think people understand what monsters these really are. Galaxies are incredibly huge. This is a galaxy that is a family of about 500 billion stars, about 500 billion stars. And it's about 100,000 light years from end to end. And let me talk about that, because light year is one of those famously confusing words in astronomy. When you hear the word year, you think it's a unit of time. But instead, it's a unit of distance, because light travels through space at 186,000 miles per second. And if you go that speed for 1 year, you cover about 6 trillion miles, and that's 1 light year. This galaxy is so huge, it's 100,000 light years from end to end. 100,000 times 6 trillion miles. And we live in a galaxy very much like this called the Milky Way. And in fact, the sun is spinning around the center of the Milky Way right now. All the stars in the galaxy orbit around a common center of mass. And right now, this room and this planet and this whole solar system is moving at about 500,000 miles an hour around the center of our galaxy. But the galaxy is so huge, it's going to take us about 250 million years to make one transit. Now, I actually like the term light year because there is a time element in it as well. This is a picture of the nearest large galaxy to us, the Andromeda galaxy. And Andromeda is 2 million light years away. So you can actually see Andromeda in the night sky tonight. It's actually up in the winter. It's kind of a little bit of a dim smudge. If you're in a dark sky area, you can definitely see it. And the light that's hitting your eyes tonight left Andromeda 2 million years ago. And it being the nearest galaxy, Hubble has made some beautiful scans of all of the millions of stars that we can see in that galaxy. And that is a 2 million-year-old image as it arrives at our telescopes at this moment. And if you were on the Andromeda galaxy and you took a picture of Earth, you'd be looking back 2 million years ago to the very dawn of humanity. So there is this time aspect too, and this becomes very profound when we look farther and farther out into the universe. Because when you look really far out, say billions of light years away, and we can do this, the universe is then billions of years old. You're looking back in time, and the universe doesn't look the same as it does today. The farthest out we can look right now with our most sensitive specialized telescopes is 13.7 billion years into the past. And this is not something that's conjectural. This is not a theory. This is actually a picture you can take. We have telescopes that are that powerful. And when you look at what the universe looked like 13.7 billion years ago, it's very different indeed. There are no galaxies. There are no stars. There are no planets. We can look back to a time when there was nothing but hydrogen gas, hydrogen and a little bit of helium. And when you look around you, I'm a being made of carbon and oxygen and nitrogen and phosphorus. The universe is somehow very different. So what happened? What happened to change the universe this way? And here's where we all come from. This is a star. This is the sun, our nearest star, and stars are giant balls of hydrogen gas. And in the very center of the star, it's hot enough, it's millions of degrees hot, that a nuclear fusion reaction is going on. Little tiny atoms of hydrogen. Hydrogen is the smallest, simplest atom. They're rammed together in a nuclear fusion reaction, and they make bigger and bigger atoms, and the star gets energy out of that, and that's what makes the star shine. And the incredible thing is that this is where every atom in the universe comes from, besides the original hydrogen and helium. And stars are amazing things. You can actually see there's a little tiny dot off to the side of the sun there that I put, and that's about the relative size of Earth. You can barely see it. You could fit about 110 Earths across the diameter of the sun, and volume-wise, you could fit 1 million Earths inside the sun. But if you think the sun is big, we talked about the scale of a galaxy. If the sun were the size of a dot of an I on a page, so if you can picture a dot of an I could contain 1 million Earths, then our galaxy, the Milky Way, would be about the size of the Earth. That's the scale of a star to a galaxy. So what happens inside a star is that bigger and bigger atoms are created. Eventually, all the hydrogen inside the core is depleted, and then the star dies. And stars like the sun unravel kind of gently back into space. This is a star that was once about the same size and mass as our sun, and it died. Its nuclear reactions died away, and all of those wonderful new atoms and elements that it created are being distributed back into space. And no two stars die the same way. This is another one, beautifully unraveling. If you are a little bit more massive than the sun, about 5 to 10 times the mass of the sun, the death isn't quite so gentle. And in fact, it explodes violently in a supernova explosion. And here's a supernova explosion remnant, kind of the leftover debris when a star exploded. This is called the Crab Nebula. And the amazing thing about supernovas, these violent star deaths, is that every atom larger than iron has to be created in this more violent explosion. And iron is the element that makes our blood red. You know, iron combined with oxygen gives you red blood. And you better believe it's actually true that whenever I bleed, I think about that. The iron that makes my blood red was created the instant a star died. Now, what happens over time is that lots of stars in the galaxy are dying and distributing their material into space. And here's a galaxy seen edge on. Instead of seeing the front of it, you're actually looking at it in the edge. And all of that dark material, trillions and trillions of miles of it, that's all debris from many dead stars. And then a beautiful thing happens in the galaxy. As the stars orbit around the galaxy, I said we're going 500,000 miles an hour, all of that dust is swept up. And you can see there are these beautiful dark spiral patterns in the galaxy, and that's all the dust being swept up by the orbits of the stars. And now something really wonderful happens. When you sweep up the dust and you form these big clouds, gravity has a chance to bring the clouds together, to clump them up, and to actually make them hot inside, hot enough to ignite a nuclear fusion reaction, and another star is born. And this is a star-forming cloud in the Carina Nebula. Hundreds of new stars are forming in there right now. This is another beautiful picture of a star-forming cloud. Wherever you see these weird little jets coming out of the cloud, that means there's a star that is just turned on. Stars, when they first turn on, are a little unstable, and they jet away from their poles. And here's another gorgeous picture from the Hubble Space Telescope of a newborn star. So over time, the stars blow away the cloud that they formed in. There's all this light and heat, radiation, winds of particles, and the sun and all of our sister stars blew away the cloud we formed in. We don't even know where it is. But it's kind of fun because a little bit of the cloud can hang around a young star. And if you're lucky enough, some of this debris will form stable orbits around the star. And these are actually baby solar systems. These are tiny young stars that have gravitationally held on to a little bit of that debris that's beginning to orbit around now. All of that wonderful and rich material, you actually give it a stable place to land on, you form a planet out of it, and pretty soon you have something like our home. And this is an actual picture of the Earth taken by the Lunar Reconnaissance Orbiter orbiting the moon right now. This is the story of where we came from. And it's a story that we had to piece together bit by bit, and that's the fun part about being a scientist. We are such brief creatures that we can't observe a star being born and living and dying. That's a billion-year journey. But instead, as a scientist, we look at millions of stars at once, and some are being born, some are living their lives, and some are dying. And we try to figure out the story. So how has this story affected me? Well, it's an amazing thing to tell you that I know where you come from, and I know where I come from. And we come from the stars, literally. You may have heard we are stardust, and you thought it was something poetic, something that was kind of a nice analogy. But your body literally had to be forged inside a star that died. And the amazing thing is that if you ever wanted a connection to a larger universe, you already have it. You don't need to go looking for it. It's right here inside you. It's not just a single star either. The sun has been around the galaxy about 20 times since our star formed. And that means that we've swept up material from stars clear across the galaxy. Stars that are hundreds of thousands of light years away when they died, we've been through their clouds, their material is in us today. So if you think the galaxy is something huge and distant, if you think astronomy is the study of things that are so far away and unrelated to you, you are the freaking galaxy, right? Right here. Right here, you are the galaxy. And sometimes people ask me, how do you cope with this sort of a view of the universe and a view of life? And I often say, I'm sorry to give you the impression if you think I've figured out how to cope with it. There are times when, like I said, I don't respond to science in an unemotional way. There are times when I feel such exultant joy. I can't believe how beautiful this is, this system that I'm a part of. And there are other times where I have these dark nights of the soul and I hide under the covers and cry. Because in my view, we are very, very brief things. My atoms come together for a little while. There's never been something quite like me or like you. You are a miracle of cosmic proportions, every single one of you out there. And it's not just other humans or other life. It's the very bones of the earth. Think about what the earth is made of, the silicon, the magnesium, the zinc, the iron, the copper, the silver. All of those were formed in the same explosions which created all of the atoms in your body right now. I often like to hike up into the mountains and sit on the rocks and feel the presence of my ancestors and my brothers and sisters. Not only are we all connected, everything here is the same thing. And sometimes I wonder as human beings why we aren't just all standing in the middle of the road embracing, being these brief things. I think in my life, I've honestly made a fool out of myself many times because I try to connect with people too strongly and too quickly. I feel like I don't have enough time. So I have let what I've learned in astronomy, I've let it fill me with joy, I've let it fill me with fear. And the story has changed me. And I don't know why we don't do more art and literature and dance and poetry about this story that we know is true. We can actually take pictures of it. So let me challenge all of you out there. I let this story change me. How's it going to change you? Thank you.